Hi everyone, in this video tutorial we will learn how to simulate 4-point bending test of concrete specimen using Abaqus. Let's start first with creating of our concrete specimen for 4-point bending test. Let's create concrete specimen, 3D deformable solid extrusion, and let's add more size. Click continue and create our sketch. Let's add dimensions 500 millimeter in the length of our specimen and 100 in the height of our specimen. And now let's add the depth of our specimen to 100. Now we have our specimen for 4-point bending test. Let's edit our dimensions. I think we have. If you need to edit your dimensions, you can go to sketch, edit, and change this value, delete first, and add a new dimension. And click done. Okay, and go to features, regenerate. Now we have a new and edited part. Let's make partitions in our part using the tone plan created with any options we have in this side. We can create the tone plan with 3 points. Let's create the tone plan in the middle of our specimen. The first one, first tone plan. Create the second tone plan. And now let's create the tone plan offset from this datum plan, create enter value, flip direction, click OK. Now we need to add 50 millimeter of offset value from this one. Let's create another one. Create datum plan with 3 points. First one, second one, third one, and create offset from this datum plan enter value in this direction. Click OK and add 50 millimeter. Let's add another datum plan enter value from the middle. Click OK, 50 millimeter, and also enter value. Okay. Let's flip the direction. Flip. Okay, 50. Now we have all that on plan. We need to create partitions in our part. Go to create partitions, select cell using datum plan, select datum plan, create partition. Now we have first cell and second. Let's go to this cell, click done, select datum plan, create partition, select cell, click done, select datum plan, create partition, and so on. Select cell, click on, select the tone plan, create partitions, and the last one. Now we have all partitions we need in our model. Now let's go to create support and ruler for our test. Let's go to create ruler, extrusion, click continue. Let's create cylindrical ruler and create a dimension. Okay, click done. Now we need to add 100 in our ruler. Now let's go to copy this part for create ruler, copy, and name it support. Now we have three parts: concrete specimen, roller, and support. Let's go to property module, and we need to import our material from library. We don't have any material in our model. Let's import these two material. Now we have these two material in our model. Let's edit the first one, concrete material. We have density. The unit of this value is on ton per millimeter cube because we have all dimensions in millimeter, and also constraint and Young model is in megapascal unit, and also any stresses in megapascal. We have concrete damage plasticity value, concrete damage, compression damage, data, and also concrete tension damage. Click OK. Now we have steel edit. We have elastic material for steel. Click OK. Okay. Now let's go to create section, concrete section. Please continue. Select concrete material. OK. And now create steel section. Okay. Select the material. Now let's assign our material or our sections to each part. The first one, support. Let's assign steel section. Steel section. Okay. And now roller. Steel section. Okay. And concrete specimen. Select the wall model, the wall part, and select concrete section. Click OK. Now each part in our model have materials. Let's go to assembly module and assembly our model. Create instance, select create offset, click apply. Now let's move each part to the right position. Let's go to assembly instance, ruler. The ruler and the support is the same dimensions and property. We don't need the dot problem. Let's hide the support ruler and move this ruler to the right position. Click translate instance, select instance, and select the starting point and the ending point. Click OK. Now let's add another ruler, apply, OK, and move to the right position. Select instance, click done, select the starting position and the ending position. Click OK. Now we have all rulers in the right position. Let's translate the support in the right position. The first one, click instance, starting position, and ending position. Click OK. add another support, apply, and move to the right position. Click OK. Now we have all parts in the right position in our assembly. Now let's go to step, create our own step, static general, continue, click and enable on for nonlinear geometry because we have nonlinear and have failure in our model, automatic stabilization, incrementation, okay. Let's go to file output, which file we need to output in our contours in our ODB. We need to get the failure of composite concrete material, damage composite, and tensile damage. Click OK. In the wall model, we need in the wall model get damage, compression damage, and tensile damage. Now, for applying our load and boundary condition, we need to add a reference point. The first reference point for this part in the bottom, the first reference point in this ruler, the second reference point, the third reference point, and the fourth reference point. Each ruler and support have reference point. Now let's go to create another reference point for applying the load in these two rollers. Create point, let's create from this point, let's move to the y direction. Now we have this point there. Let's create a reference point in this coordinate, tool, reference point. Now we have reference point in this coordinate. Applying our load. In this point, we need to get reaction force and displacement. Let's create set in this point. Set, change to data curve. This reference point, click done. Let's go to create history output, create, continue, and select the set where we need to get our displacement and reaction force in the y direction. Go to select the displacement in the y direction and also the reaction force in the y direction. Click OK. Now let's go to interaction module and we need to create rigid body for and converting roller and support to rigid body. Constraint 1, rigid body, continue, select body, select this part instance, select reference point, click OK. Now this ruler, this support in the bottom, analytic as rigid body. The second rigid body, click continue, select body, select reference point, click OK. The third one, continue, select body, and also select reference point. Click OK. The last one, rigid body, continue. Okay, now all rollers and supports change it to rigid body. Now let's go to create coupling between rollers to apply our load. Constraint 4, constraint 5, coupling. Continue. We need to select control point in this point. Click done and select surfaces where we need to add coupling options. Surface, the first surface and the second surface. Click OK in all directions, and we have many data in this. Constrained degree of freedom in all directions. Click OK. Now we have coupling, and all these two parts rulers are depending to the master points in boundary condition and apply and load. Now let's go to create contacts property, create interaction property 1, continue, tangential with friction coefficient of 3, and also mechanical normal behavior with hard contacts. Click OK. Now let's go to find contact pairs and find contact pairs in our model automatically. The first one, first contact between ruler and upper surface of our specimen. Also in the bottom between support and bottom surface of our specimen, between ruler and upper surface, between support and upper surface. Click. We can change type of interaction and also change property and adjustment. Click OK. Now we have all interaction and constraint are applied. Let's go to load module and apply our boundary condition in our model. First one, on caster in the initial step, on caster in two supports we have. The first one, shift, second one, select, done, and click on caster. Click OK. Now in initial step, continue in the controlling point of coupling interaction. Click done. Now we need to displacement rotation. Click OK. Controlling point select. Click done and select all these directions without selecting the displacement and in the y direction. Now let's apply our load. Displacement, initial step, displacement rotation, continue, select controlling point, done, and add displacement in the y direction minus 2 millimeter or millimeter, for example. Click OK. Now we apply displacement in this direction in our model. Let's go to mesh, parts, 10 millimeter, apply OK. Mesh, yes. 3D standard linear reduced integration, and also we need to add element degradation, deletion, and also maximum degradation 0.5. Ruler size 5 millimeter. Okay, apply mesh, yes, and also support 5 millimeter. Apply OK, yes. Let's go to assembly. Now we have We have all parts are meshed. Now let's go to create our job. Create. Continue. Okay, and let's check our model. Data check. Submitted. Running. Aborted. We have an errors. Monitor. We have set not been defined. Pick it. Let's go to the result, and we need to which node they talk about. Node. Now we have this problem in boundary condition. Let's go to warning, and we have an error and warning. That means the coupling constraint will not be applied at a node that be belong of rigid body. And because we have these two parts interaction, these two parts as rigid body, we can't apply coupling for these two parts. Let's we can remove this coupling or remove rigid body, but we need this rigid body for roller. Let's go to I think we can remove coupling. Click. We have done. We have enabled our coupling and apply boundary condition in each ruler. Let's delete this boundary condition. Delete. Yes. And also delete this boundary condition because we don't have coupling. Yes. And now we go to apply displacement in each ruler. Let's go to boundary condition, displacement rotation, and select displacement. Boundary condition. Click OK. Now apply displacement. In the initial step, displacement rotation, click continue. Select the first reference point, second reference point, click on and apply displacement in this rigid body. -2 mm. Click OK. Now we have applied displacement in each ruler. Let's go to check our model again. Data check. OK. Completed. Continue our process. Continue. Submitted. We have completed job. Let's go to the results. Visualization module. Deformed shape. Let's remove edges. Apply. Mice stresses. Animation. Our model. Simulation. Let's go to plot the damage contours. Compression damage. And tensile damage. That's all for this video. I hope you to enjoy with this video. Don't forget to subscribe in my YouTube channel and like this video. See you in the next video.